All right, welcome to lesson 2-21. So this is unit 2, lesson 21. And this is the second part of rational equations. It says, let's write, that's the eraser, let's write and solve some more rational equations. So this is the second part of it. It asks us to solve these mentally. These are proportions. Proportions are two equal fractions. So if I look here, I see two equal fractions. Well, 2 doubled to 4. 4 halves to 2. So 3 becomes x. What do I have to do? That's right, cut the 3 in half. So x is 1.5. Same thing here. Look here. 3 becomes 1. 1 becomes 3. 1 becomes 3. That means it's 3 times as much. So 6 needs to go to 3 times as much. That's right. X is 18. Something squared. Oh, so we kind of went over this. If the denominators are the same, the numerators are the same. Well, the numerators are the same, so the denominators need to be the same. So something squared is equal to 4. Now, this is what always gets people, is the fact that it's not just 2 squared, it's also negative 2. So x is 2, x is negative 2, and we write it, x is plus or minus 2. That's the fast way to do it. So those are the two answers for that one. This one also has two answers. Each one of these needs to be a half. So if I put a 4 down here, 2 over 4 is a half, and then 4 over 8 is a half. So x is equal to 4, but also negative 4 works as well. So x, again, is plus or minus 4. So we have the rational river. They're using alliteration. Good for them. This is distance, rate, and time problem. So we know that distance is equal to rate times time. So we know on this problem that the times are the same. That's what it says here, and we'll read through it together. So since the times are the same, we're looking for times. We're going to do distance divided by rate. So Noah is on a boat. Imagine that. So we're kicking it Old Testament. Noah's on a boat, maybe 40 days and 40 nights. Noah likes to go for boat rides along a river with his family and animals 2 by 2. In still water, the boat travels at 8 kilometers per hour. In the river, it takes them the same amount of time to go upstream at 5 kilometers per hour and downstream to travel 10 kilometers per hour. So upstream, you can't go as far. So you can only go 5 kilometers upstream. Well, the water's working against you. And downstream, the water's going with you. So find the speed, if the speed of the river is r, write an expression for the time. What is time? Distance divided by rate. It takes to travel 5 kilometers upstream and 1 for 10 kilometers downstream. So I'm going to write the upstream equation first. Upstream. How far are we going upstream? We're going 5. And my rate is the boat, which is 8 miles an hour. I'm going to be subtracting off the rate of the river because the river is working against us. So that's my upstream time. 5 divided by 8 minus r. Downstream is the same idea. Distance, downstream was 10. And my rate is going with the river, so it's going to be 8 plus r. So the next page, we're going to say, hey, these two fractions are equal fractions. So that's what's going on here. We have to solve for r to find the rate of the, did I go too fast? So I got the two fractions, now I'm going to set them equal to each other. So use the expressions to find the speed of the river. All right, so we have 5 is equal to 10. 5 is 8 minus the river, and this would be 8 plus the river speed. So up the river, down the river. Now what's kind of funny about this picture right here is they don't look like on a river, they look like they're on a lake. But, you know, it is what it is. It's a math book. So I'm going to switch here. What do we know? If the numerators are the same, the denominators are, oh, sorry, I said that backwards. If the denominators are the same, then the numerators are the same. So each one of these needs to be the same here on the bottom of the fraction, the denominator. So this one needs an 8 minus r. And remember from before, if we multiply the bottom by something, you got to do the same thing on the top. And then this needs an 8 plus r. So I'm going to multiply by 8 plus r, 8 plus r. So look here, we did it. This is the same as this. Since the denominators are the same, the numerators are the same. So I can set the numerators equal to each other. So I get 5 times the quantity 8 plus r is equal to 10 times the quantity 8 minus r. Now, what would your Algebra 1 teacher tell you to do? Because this is suddenly an Algebra 1 problem. That's right, distribute. So we're going to distribute the 5 through the parentheses, get 40 plus 5r is equal to 80 minus 10r. And then the way I always solve these is to move the smaller amount of r in the parentheses, or in the equation. So I'm going to move the 10r. So I'm going to add 10r to each side. So 40 plus 15r is equal to 80. And subtract 40, subtract 40. We get 15r is equal to 40. So then I just divide by 15. And we can get the fraction r is equal to 40 15ths, which would be 8 thirds. And this is miles per hour, kilometers per hour, I forget. Look back here at the problem. Oh, it's all in kilometers, so it's going to be kilometers per hour. So that's kilometers per hour, and a decimal would work too. That's 2.6 repeating kilometers per hour. That's how fast the river's going. And it makes sense when you're going with the river. When you're going with the river, you can go 10 kilometers. When you're going against the river, you can go only 5 kilometers if the times are going to be the same. So we set the two fractions equal to each other, and the two fractions were the upstream time, right? So that's a time, and the downstream time, that's a time. So we set the two fractions equal to each other. How do we get the fractions? Distance divided by rate. Distance divided by rate is time. Now we're going to do rational resistance. Oh, they're so funny. Look at this. Rational river, rational resistance. So this is an equation right out of science class. Your total resistance can be represented by all these fractions. So if you take the resistances and the individual things, it's equal to the total resistance if it's all flipped upside down and added together. It says circuits in parallel follow this law. The inverse of the total resistance is the sum of the inverses of each individual resistance. We can write this as blank, where there are in parallel circuits. So there's a whole bunch of circuits, and R of T is a total resistance, and it's measured in ohms. Ohm. So you have two circuits in parallel. The first circuit has a resistance of 40. So that's your first R. So that would be the first R. The second is R, I guess we'll call this R1, R2. So the total resistance would be just the first resistance, which is 40, plus the second resistance, which is 60. We add those together, and we get the total resistance. So I'll put that back here, RT, total resistance. So basically, I just got to add those two fractions together and represent it as 1 over something. Okay, so fractions are common denominator. You can use a calculator. I'm going to use my brain here. So I need a common denominator of 120. So 120. So 40 becomes 120, so that's going to be 3. 3 over 120 is 140. 120 is the common denominator. That means I'm doubling, so I get 2. Now I can add these together. 5 over 120. All right, now it has to be in the form of 1 over the total resistance. That's not a 1. But if you reduce this fraction here, if you divide by 5 and divide by 5, you get 1 over 24. So now it's in the correct format. So the total resistance is RT, 24. Total resistance, 24. So if one resistance is 40, another resistance is 60, you add those together and you get 1 over 24, which is the total resistance. Okay, now we're going to do 2 circuits, and the one circuit has a resistance of 150 ohms more than the first one. Write an expression for the following showing the relation. So 1 over RT, that's the total resistance. We got the first resistance is just R, and then the second resistance is 150 more. So how do I add 150 more? Well, I take R and I add 150. So there's the equation for this. So the directions, remember, the goal of this is to write some equations and solve some equations. So 1 over R is your first resistance, 1 over R plus 50 is your second resistance. These are fractions. We're adding these fractions together to get our total resistance. And that's what I did up here. 1 over 40 plus 1 over 60 made 5 over 120, reduced the fraction 1 over 40. So it has to be in this format of all ones on the top and then the R's on the bottom are your individual resistances or your total resistance. Okay, next page. It says, for this circuit, Claire wants to use graphs to estimate the resistance of the first circuit R if R of T is 85 ohms. Describe how she could do this with a graph. So here we go. We're going to have 1 over 85 is equal to, that's the answer, 85, 1 over R plus 1 over R plus 150. So what you would do is you can graph this. So on your graphing calculator, you would type this in first. You would make this y1. And then you would type this in second and make it y2. So you graph each equation and you see where they cross. Now I did this with GeoGebra. So I typed these in. So you can see up here under the F in this part right up here. See where I'm making the little marky thing? I did 1 over 85. Then I typed in the next part, and it doesn't want to display it, does it? It keeps disappearing, but you can kind of see it's right there. It's 1 over x plus 1 over x plus 150. Look, let's see, can I click right there? Yeah. Forward, forward, forward. There you can see the 150. Then I graph these, and it's a really funky graph. Let's see, can I make this disappear? There, oops. There we go, and it disappeared. Well, these don't cross each other very easily. So the blue line is the second equation, the G equation, the red one, and it intersects, like, they're so close together here, but it intersects around 123. Now if we go back to, like, the original graph, I'm going to go way over here. So it looks kind of like that. So 1 over 85 is a very small number. It's just barely there. And then the blue line is the G function. And they do intersect, but it's clear out around 123. Oh, there's the intersection point. It shows me it. There's that dot. That's the intersection point. Oh, yeah, I even clicked on it. So it's 123.35. There you go. So that's the program put a dot there for us. And I clicked on the dot and it told me 123. Okay, so I'm going to go back to here. So you graph y equals 1 over 85, and then you graph 1 over, well, maybe change that to y equals 1 over x, because your graphing calculator has to do x, plus 1 over x plus 150. Put parentheses there. So you graph these two things, and then you look for the intersection. That's how you do it. And it intersects about x, which is R, 123, and that would be resistance ohms. The algebra way on that is pretty intense, and we'll get into some of that. But it just says for this circuit, she wants to, or I guess you could keep putting in x values until you kind of got something close to 1 over 185. You do guess and check too. Describe how she would graph to determine the value of R. So we graphed this first. Graph this first, which is a horizontal line. Graph this second, which is a curvy thing. And then you look for the intersection, which is about 123 ohms. All right, so we're skipping that part. And then here's the summary. This summarizes the river problem. So we got 2 times here. So we got this time and that time are equal. And then they came up with this, and they solved it out, and they found the rate of the river was 3. So that's similar to our problem there. Okay, so you're going to take a look at these ones here and solve them. They don't give you a lot of space, do they? And then the new ones, or the old ones, are here, and it's just 7 questions like normal. So for number 2, right, what's our procedure here? For number 2, I'm just using this space right here. So we have 4 over x minus 4 is equal to 5 over x plus 4, right? Well, 4 plus x. Let's not confuse you. Let's write it the same way. 4 plus x. So what do? We go ahead and make them the same, right? So this one here, first one has an x minus 4. This one needs x minus 4, 4 minus x. Right? So now that's good. And then this one needs a 4 plus x. So now they're the same, right? So the denominators are the same. What's the rule? Then the numerators are the same. So now you can set that equal to that and solve it. So that's the deal with that. All right, good luck with the purple pages, which are 225 and 226. Peace out.